Hi students, audible?
Yes, sir.
Today students, less students are. Okay, yesterday class we seen that is the tautological implications. In that we seen that is converse, inverse, contrapositive. So condition is P conditional Q and its converse is Q conditional P, and its inverse is negation P conditional negation Q, and its contrapositive is negation Q conditional negation P. Okay, so this we seen the converse, inverse, contrapositive, very important concept, 2 marks definite question. Okay, and so we solve the example also, and we solve the truth table of converse, inverse, contrapositive. From the truth table, we give the two result we got from the truth table. That is, conditional and contrapositive are both are logically equivalent, and converse and inverse are both are logically equivalent. Okay, so this is the we seen yesterday. Okay, up to this, anyone having doubt? No doubt, right? No doubt, I think. Okay, so
Notes.
okay, next we go to the in the logical implication only. So total this whole concept is tautological implication. We also call that is logical implications. Okay, so inside that sub concept we studied, that is converse, inverse, contrapositive, and the main concept we have to study here. So that is logical implications. Okay, so here there is a two statement or proposition will be same only. So proposition we can also call statement. Okay, so a statement or proposition, that is a two statement is there, that is two primary statement. Okay, so 6 is multiple of 2 and q is 3 is a prime number. Okay, so here there is a two primary statement, and we indicated that is the English alphabet letter, that is p and q, and from this sentence we do the that is a compound proposition, that is by using conditional connective. So that is p conditional q, and it can be written as here, if we use the in the conditional if comma then, and in between first sentence and second sentence. So this is the format of conditional statements. Okay, so first sentence, that is if 6 is multiple of 2 and 3 is a prime number. See, in the first statement, p statement, it is telling that it is telling multiple number. Okay, and second sentence, that is telling prime number. Okay, so what is the prime number? Anyone idea about it? Prime number. Hello?
Which numbers are
A
divisible
number which
itself
divides
and
by
then 1?
itself.
Divisible by itself and 1. Okay, so that is
1.
yeah, prime number. Okay, 3 is a prime number, 6 is a multiple of 2. So P sentence is telling multiplication and Q sentence is telling prime number. Okay, so there is no relationship between both the sentence. Then also we combine both sentence by using conditional. Okay, so remember here there is in the logical any logical statement there is no relationship between both the sentences. We already seen in the compound statement there is no relationship between both the sentence, then also we are combining the sentences, primary standard sentences. Okay, so there is no relationship between them, then also we can say that it is logically true. Okay, understand or not? There is no relationship between both, only we are putting the first sentence and second sentence in between conditional symbol. Okay, so that's there. Okay, there is no relationship between what, if relationship is there, so what type of relationship and which relationship we cannot we cannot do that one. Okay, so only how to give the only how to combine the sentences, that's it, that's only, that is we can, that will be that will be applicable in the logical. Okay, so there is no relationship between, also we can combine the sentence. So this is the one example. Second example here, consider the proposition p, 4 is an odd number. See here the sentence 4 is, the 4 is odd number. Okay, so 4 is odd number, 4 is,
No, sir.
No, sir. It is even number.
yeah, it is even number, so this is sentence false. Okay, so in second sentence, that is true, Bengaluru is not in Karnataka. Okay, so but the Bengaluru is also in Karnataka, so this sentence also is false. Then also the both the sentence, both the primary statement is false only, but then also we can combine by using the conditional statement. So see here, if 4 is an odd number, then Bengaluru is not in Karnataka. Okay, so then also it will, then also that will be that will be available in the logical. Okay, then that also permit, the permission will be there in the logical. Okay, so then also that is logically true only. Okay, so this is the conditional statements. Okay, so ultimate, there is no relationship between any sentences, so we are combining sentences by using some connective symbols. Okay, so and if some relationship is there, relationship between both sentences is there, so and we cannot go to the what type of relationship and which type of relationship and how they are relationship between both, so we cannot go to the relationship, but they are connecting some way. They are relationship between some way, the relationship is there. Okay, so that is the uh, that is there in the logical. Okay, so any doubt up to this?
No,
No,
sir.
sir.
Sir, sir, if one statement is true and another one is false, means
Then
last sentence how it will be written, sir?
no, then also it is possible to combine. Okay, then also possible to combine, there is no relationship between any sentence, any type of sentence you can combine the sentences by using any connective symbol, so that is there. Okay, so that will be available in the logical, but in the logical we can say that true. So this is any doubt?
No,
No,
sir.
sir. No, sir.
ಸೊ ಯಾವುದು ಎರಡು ಸೆಂಟೆನ್ಸ್ ನಾವು ಕಂಬೈನ್ ಮಾಡ್ಬೋದು, ಏನು ಸೆಂಟೆನ್ಸ್ ಇಲ್ಲ, ರಾಂಗ್ ಇರಲಿ ಟ್ರೂ ಇರಲಿ, ಬಟ್ ನಾವು ಸೆಂಟೆನ್ಸ್ ಕಂಬೈನ್ ಮಾಡ್ಬೋದು, ಬಟ್ ಅವು ಎರಡು ಸೆಂಟೆನ್ಸ್ಗೆ ಏನು ರಿಲೇಶನ್ಶಿಪ್ ಎಲ್ಲಾದ್ರೂ ಕಂಬೈನ್ ಮಾಡ್ಬೋದು. ಸೊ ದಿಸ್ ಇಸ್ ದ ದಟ್ ವಿಲ್ ಬಿ available in the logical, and in that will you can say both logically true, that sentence, whole sentence is you can say logically true. Okay, so ultimate, the main definition of logical implication, see the definition of logical implication or tautological implication is, in a conditional, in a, in a conditional p conditional q, where p and q are related in some way, related relationship is there, but what type of relationship, which type of relationship, so that is no, we will not see that one. Okay, only relationship is there, some way relationship is there. So that truth value, so that the truth value of q is depends upon the truth value of p. or vice versa. See here. So P conditional Q, here Q truth value depends upon P and P truth value depends upon Q. So this is there. Okay, so that is called hypothetical statement or implicative statement. Okay, or also we can call logical implication or tautological implications. Okay, so any doubt?
No, sir.
There is a conditional Q. There is a both sentences will be relating some way. Okay, and Q value is depends upon P and P values depends upon Q, and this is called logically implications or implicative statement or hypothetical statements. Okay, so and how to represent the symbol of implications here. Okay, so here when a implicative statement or any logical implication statement P conditional Q such that Q is true whenever P is true. Okay, so this is very important. So when Q is true, then P is true. Both true only, we can say that P is implies Q, or we can also say P is logically implies Q. This is we symbolically we can write this symbol. That is this symbol, very important. This symbol is called implication symbol or implies. P implies Q. We can read as P implies Q, and symbol is this one. So denoting this is for implications or implies. Okay, any doubt?
No,
No,
sir.
sir.
Implication. When P is true, then Q is also true. Okay, so this is the implicant. Then we can say that P is implies Q, or you can also say P is logically implies Q. So this is the implicative or hypothetical statements. Okay. So next, if not implies, what to say that one? So there is next definition. When implicative statement, when implicative statement P conditional, wait, implicative statement P conditional Q is such that Q is not necessarily true whenever P is true. See here, P is true, but Q is false. So that time what to say? So that time P does not implies Q. So this is we can say. Suppose suppose if a P is true, Q is true, we can say that P is implies Q. Suppose P is here. Suppose P is true, Q is true. Both are true means we can say that P is implies Q. If P is true, Q is false. So that time P is does not imply Q. We can say that. Okay. So and this symbol we can represent like this. The whatever the implies implication symbol, and we can give the one bar for that. Okay. So that is does not imply. The symbol we represent for does not imply. Okay. So we can say that we can read as a does not imply. So P does not imply Q. So any doubt? Any doubt? Hello? Hello? Now audible?
Yes, sir.
Some network problem that will be disconnected again connected. So I will share again screen. Okay. So understand this one does not imply. Hello?
Yeah, sir, it is understood.
So go to the next point. So that next one, the tautological implication, we can say that this is how we represent that is PQ. So here same also A and B is there. So A is implies B. So guarantees that B has a truth value true whenever A has truth value true. Okay. So A is true and B is true. Then also that is both are implications implied. Both are implied. So that's why A implies B. Okay. So in order to show any of the given tautology implication, it is sufficient to assign the truth value true and to the antecedent. Antecedent. We also seen in the P conditional Q. Okay, so in the P we can say that is antecedent, and Q we can say that consequent. So same here in implies also, P is called antecedent and Q is called consequent. Okay, this one is studied in, already studied in conditional statement, conditional connective symbol. Okay, so that time we studied that is antecedent is this one and this is consequent. Same also in implies also we can say this is antecedent and this is consequent. Okay, so see here, there is some problems based on this logical implication. There is a very easy also. See here, how to prove the both the whatever antecedent and consequent are logically implication. So how to prove that one by using truth table. Okay, so see here, prove the, so how already we discussed about logical equivalence. To prove the logical equivalence, what we did by using truth table also, we proved that both are logical equivalents. Okay, LHS and RHS formula, and also we using laws of logic also we are used, and we are proved that both are logical equivalent. So same here, the both whatever this antecedent and consequent, we have to prove both are logically implied or implies. Okay, so that time you have to use the truth table. See here, so first construct a truth table, whatever the given statements, whatever the given proposition. So P conjunction P conditional Q is there, implies Q. Okay, so here first has to, there is a in the sentence, in the statement there is a two variable is there. So two variable means 2 raised to 2 means that is 4 possibility will be there. Okay, so PQ is there. So true true, false false, true false, true false. Okay, so next here, see here, P conditional Q. See here, P conditional Q means that is whenever in the conditional true, whenever first sentence is true, second sentence is false, then false, in all other cases true only. Okay, so true true, true in conditional, true false, false, false true, true, false false, true. So this is we did the conditional. Okay, because why we did condition first time, condition, because the bracket will be the whatever this conjunction will be to hold this condition. So that's why first do the condition, next we P conjunction with this condition. Okay, so P is there, we have this condition, so do in between we have the conjunction symbol, so and operation. So do the and conjunction operation, that is both are true true, either one false means false, and all two both false means false only. Okay, so in the conjunction, true true, true, true false, false, false true, false, false true, false. Okay, and here how to show that both are logically implies. See here, in this is we can say antecedent, so this is a true and Q is also true, then we can say that is logically implied. See, any rows, any one row, it is sufficient to prove. Okay, so any row that is a true for this statement, this whole statement, and true for Q, so that we can say that both are implied. See here, in Q is a true here, and here also this is true, so that's why this is logically implied. Okay, and we cannot go to the next row, this is false, so this is also false, we cannot say that does not imply. So that only one row, that is sufficient to prove the implication. Okay, so and you can write the below, that is from the above table we find that when this P conjunction P conditional Q true. Okay, so true is there, then Q is also true, Q is also true is there. This proves that P conjunction, this P conjunction P conditional Q is logic, is implies Q. We can say by using this row. Any doubt? Any doubt?
No, sir.
All of you understand that?
Yes, sir.
Yes, sir.
Any one implications. True is there, true is there. Okay, so whatever this whole statement is true, this is true, and Q is a true. So we can, and one more thing, here is true and here is true. We cannot say that one. Only single row only it has to be there. True, true. So then only you can say that both are logically implication. Okay. So this is one example. So we go to the next second example. That is P conditional Q conjunction negation Q. here. So first we do the conditional Q, next we do the negation Q, and then in between we have the conjunction. Okay. So there is a two variable PQ. PQ is there. So there is possibility for true, true, false, false, true, false, true, false. And first we need the negation Q. So do the negation of true means false, false means true, true means false, false means true. Okay. So next there is a P conditional Q. We want P conditional Q, we did negation q, then after that we do the conjunction. Okay, so p conditional q, so true, 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 wait a second, true, 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 that is true, true, false, that is false, false, true in true, false, false, true in conditional. Okay, so next there is that is p condition q conjunction negation q. Okay, so do the in between both these we do the conjunction. So false true, that is false only, true false, false only, false true, that is we did the wait, false true, that is this column you have to see the false true, that is false, true false, that is false, false true, that is false only, so true true, that is true. Okay, so here we did the this antecedent. Okay, so next to do the consequent. So consequent is negation p is there, so we have the p, do the negation p. Okay, so here, so do the negation p. So it is a true true is there, so you have to false false, false false, that is true true. Okay, so and here this is the antecedent and this is consequent. Okay, so this is, we can consider this is a p and this is a q, and in between there is a implication. Okay, so so this here there is a, we want to true true both in any row. Okay, so here is true is there, this is the true and this is true, we can say that both are logically implies. Okay, so this is from the above table we find that conditional q conjunction negation q is true, and negation p is true, this is negation p is true, and this proves that both the p conditional q conjunction negation q implies negation. Okay, so finally we have to uh, write one line. Okay, so any row it is some problems that is possible, there is a two row for true true, so that is there. Only only we highlight the one row, that is sufficient. At least one row has to be there, true true, then only you can say that p is implies q. Okay, any doubt?
No, sir.
Okay.
No, sir.
This is the simple example, and I given two homework. Okay, C and D questions you can solve in home. So in the D, first PQR is there, so that is number of possibility will be 8, and first do the disjunction R, then do with disjunction with P. After this with negation Q with the conjunction operation. After this we do the P disjunction R. Then in the table you can see wherever the both are true true. So that time we can say that both are implied. So this is the whole about tautological implication or logical implications. So any doubt about this concept? This concept is over. Okay. And whatever this audio I will upload in the YouTube, so you can see there. And when college will start offline, we'll only have to uh, just we do the fast explanation. Okay, we cannot go to depth explanation. Already I taught all the concept clearly, and also we have uploaded videos. Okay, so I will not to go depth, I will not go to the depth in the class. Okay, just I will go to the next concept only. Okay. So anyone having doubt about implication, converse, inverse, contrapositive, implication? There is a four concept in this whole concept. Understand it. All are
Sir, you'll send PDF now, sir.
yeah, immediately I'll send you after. Okay. I will send this PDF and also I will upload about this audio recorded audio in YouTube and I will send you.
So from when college is going to start, sir?
Yesterday and then they are given. Still notification has to come Monday maybe. And this is all about some remaining concept is there. We have concept is available and not that will be studied Tuesday. Monday is Monday holiday. Tuesday will be so anyone having doubt means please,
No, sir.
I will end the session. Can I end?
Okay, sir.
Yes, sir.
Thank you for joining the session. So we'll see the Tuesday. Okay. So study this concept right in the DMS notebook. Okay. Thank you. Thank you all.